So it's nice meeting you all. I'm Shobna, TME for Aruba campus switching. So I'll be presenting one of the 10.13 release anchor feature based out of security theme. So it is the much asked device profile over lag support. So basically it is the phase one of port access security features supported over lag. So we have planned for other phases in the future software releases. So first let's start with the overview. So let's hear the background behind this enhancement. So the security challenges have significantly evolved over the years in our campus environment. So here are the current two edges of that sword. The first one is device visibility. So with the increased adoption of IoT and visibility of devices and users on the network has become an increasingly important and a challenging task. So without the visibility, the critical security controls that support our zero trust model are difficult to apply. Adding to it, the ability to quickly identify the device types are really important. So in the recent past, the device visibility challenge is defeated by rich set of features span across our entire Aruba ESP solution, like be it our switches or ClearPass or Central. But still we encounter other problems. So top of that list, or we can call the other edge of the sword as the onboarding latency. So consider a campus of branch deployment. So where we have APs connected to the access switches, and we have the network access control servers like ClearPass over the WAN. So it may create a latency in secure onboarding of APs, as every time the authentication radius request has to reach over the WAN and respond in the similar path. So this delays the quick onboarding of APs in many deployments. So this does not solve here. So if there is a delay in onboarding the AP, it will result in delay in onboarding the clients behind it. So that cannot be bad by most of the networks. So how do we solve that challenge? So let's hear about it further. Yes, the device profile comes to the rescue in such use cases. So we'll see in detail about it. So first, what is device profile? So device profiles are used to dynamically assign port attributes. Those attributes are contained in a rule, and those attributes are applied based on the type of device connected. So those does not require any radius infrastructure. So thereby it helps in faster and secure onboarding of APs, especially because we are not looking for the radius infrastructure here. So how this device profile works? So the device profiles are mapped to device groups. How do we identify those device groups? So these device groups could be identified based on the packet received from the device and matching the data present in the packet. Like it could be a LLDP match, CDP match, or based on the source address match that we call it as the local MAC match. So all these kind of matches can be helped to create a group, and that group will be applied for the device profiles. So prior to 10.13, the device profiles can be applied only on the physical L2 ports. So let's see what is the enhancement in this 10.13 release. So before we understand the enhancements in 10.13 release, I wanted to share some background about the device profile modes. The first one is a colorless deployment. So what is a colorless deployment? Where if we have end devices connected to the access switches, we do not need to remember which port is connected with which end device. So the admin no longer need to make a remembrance that this port will have only the AP connected. So for that purpose, he will have same set of configuration across all the ports in the switch. So that's the reason we call such deployment as a colorless deployment. So this is the sample configuration for a colorless deployment where we have end client that can be either authenticated via .1x or MAC authentication or via the device profile. So how do we achieve this? Let's watch this configuration. Foremost is .1x authentication enablement, and next is the MACauth enablement. The other thing, as we discussed earlier, how do we onboard APs? So APs can be onboarded using device profile. So in the same port, if we connect the AP, there should be a way to first onboard the APs using device profile rather than trying the .NX or MacAuth for the AP. Hence, we configure a onboarding precedence. We make sure device profile is first precedence than the AAA, that is .NX or Mac authentication. So this configuration will remain the same in all the ports. So in case if there is no device profile match, then the fallback will be the .NX or the Mac authentication. So once this has been enabled in a port, what happens is with security by default, if there is no client onboarded, all the packets will be dropped. Not only the general packets, even the LLDP and CDP packets also will be dropped until the clients is getting onboarded. But in case of APs and all, we need those packets to be identified for further processing of the AP type. For that reason, we will try to bypass those LLDP and CDP packets. Hence, this CLI is required for bypassing those LLDP and CDP packets from the security. So this is the colorless port configuration. So next we'll see about the color deployment. So in the color deployment, the admin knows which port has been connected with which type of end device. Hence, they can have specific configurations for the AP connected port, and then for rest of the end clients connected port, they can have a different set of configuration. So in that case, what is the configuration to securely onboard a AP? The first thing is, as I said earlier, when security is enabled, by default, all the packets will be blocked until the client gets onboarded. So we need to allow the LLDP and CDP packets to be received by that LLDP or CDP models for further processing. So we will try to bypass those packets using this allow LLDP BPDU and allow CDP BPDU CLIs. And next, the security is controlled mainly with this CLI in case of device profile. So it is under the device profile context. So where we call it as port access device profile and mode as block until profile applied. That means when device profile is enabled on the switch, by default, all the ports will be in unblocked state. Only when you try to configure the CLIs block until profile applied, then only the blocking of the secure port will happen. Hence, for secure onboarding of APs or end devices over the device profile, it is becomes mandatory to configure the CLI port access device profile mode as block until profile applied. So this is the difference between a device profile configuration over a colorless or in case of a color deployment. So let's hear about the enhancements in device profile in this 10.13 release. So foremost, what is LAG? LAG is a link aggregation group. It bundles multiple physical Ethernet links into one logical link. So what are the benefits of using a LAG interface in our switches? So it increases the bandwidth and it improves the link reliability. So with the 10.13 release, the device profiles are now supported over the L2 LAG interfaces. That is the enhancement as part of this release. So how does it happens? So the roles are mapped to the configure device group. As I said, the match criteria is a device group. It can be either LLDP, CDP or MAC based. And then it is applied on the whole lag, not on the individual ports. The whole lag, the device profile configuration will be applied. So based on the end device connected over the lag, if there is a match, then the configure device profile and its associated role will be applied for those devices. So here is the list of platforms supported for this feature in this release. 4100i, all the 6000 series switches, 8200i and 8360. So let's see the use cases this feature is trying to solve. The foremost one is the enterprise camper connected with a dual port APs. So consider an enterprise campus where there is a three-layer architecture. So where we have the access layer, aggregation layer, and then the core. We will have the access points connected to the aggregation layer, and they form a GRA overlay tunnel to the gateways. So in this deployments, the APs can be either connected to the 6300 VSF box or a 6400 chassis based boxes. So let's see the deployment here. So the first is a AP connected to a 6300 VSF box. So if we could see here, I have used a dual port of that AP to this 6300 VSF box. So where the first port is connected to the conductor and the second port is connected to the standby, or it can be also to the member, and the lag has been formed for the connectivity. So the advantage of this deployment is APs can have both path redundancy, POA redundancy, and then the throughput can be increased because once if there is a conductor failure, the standby will be active. So the other port in the AP can regain the path to the network. So the next deployment is the with the 6400 chassis based boxes where the AP ports can be connected to the line cards, like it can connect to different line cards of the chassis. So one port to a line card one, another port to the other line card to the lag interface. Similarly, if there is any line card failure, that can also be handled using the other port. So why do we need such dual port APs in our deployments? So let's see about it. The major objective of a dual port APE is providing better wireless service reliability and then performance. In earlier days, we had only the single uplink APs. So in that case, we do not have any POA redundancy or path redundancy, or there is no throughput. Later on, and currently this is the deployment being used. It is a dual port AP where we have active and standby mode. That is when AP is dual connected to switch ports and LSCP is not detected, the internal bond on the AP will operate in an active and then a standby mode. Like the Ethernet port 0 will be active and Ethernet port 1 will be the standby. Like during normal operation, all the management and then control and user traffic will use only the Ethernet 0 port, and all the internal IP traffic also will be bound to the Ethernet 0 port's MAC address. So the Ethernet 1 port will be active, but it only transmit the LLDP videos. So only if the link state of Ethernet 0 goes down, the internal bond transitions the state of the AP from Ethernet 0 to the Ethernet 1 and it becomes the active. But still the AP will maintain the Ethernet 0's MAC address for management control and then the user traffic. So with this deployment currently being used in most of our customer environments, it is having POA redundancy. So we can have this APs connected to the different ports of the switch. Path redundancy also can be achieved, but there is no aggregated throughput available because it works only in active and then the standby mode. And the next one is the active one. That is one of the most requested asks currently. Because of this enhancement, it will be highly achievable in our customer environments. So when the AP is dual connected to the switch ports and LACP is detected on both the ports, the internal bond on the AP will operate in active mode. So as a logical bond is used, the SMAC, that is the source MAC of the frames and package will be the AP's Ethernet 0's MAC. So regardless of whether both the ports are up or either one of them is active, only the Ethernet 0's source MAC will be used for the traffic. So with this dual port AP with LACP detect, we could achieve POA redundancy, path redundancy, and then aggregated throughput. So with that, it becomes a highly required feature for a dual port AP environment. So far we have seen only about the APs. So let's see what other use case this feature can help in. So let me explain with a particular use case, and this use case can be extended to other verticals as well. So consider a hospitality vertical where we have a hospital building and then It has a remote DC where the server formats exist and the services are present. So we have the 6300 VSF 24 or 48 port access switches connected over the access layer to the 6400 VSX core switches. So in a medical building, they will have lot of end devices connected to this 24 and 48 port access switches. Apart from the main building, they will have other medical rooms, or in case of a manufacturing vertical, they will have the industrial switches placed in the outside environments. So these medical rooms or in the outside rooms, like in a manufacturing verticals, what happens is they will have limited number of end devices in such spaces, like they will have around 8 to 12 end devices in such spaces. So they wanted to secure even those end devices because they are in an isolated environment. So how do they do it? So they will try to deploy the mini access switches like a 12 port 6200 or the 4100i series. So when these switches are connected to the main access switches, they can able to do the extension of the access. So they call it as a secure access extension. So before 10.13, so these devices could not be able to connect it over lag for secure onboarding because we do not support .1x or MAC authentication over the lag interface. So with 10.13 release, instead of .1x and MAC authentication, we can deploy device profile for securely onboarding these mini access switches. And once these mini access switches are onboarded, later on, they will have the connectivity to the rest of the campus, and then they can onboard the other medical equipments or end devices connected in such isolated spaces. So thereby we can able to achieve our zero trust security. Even if the switches are connected in a hostile environment, also they can be connected to the main access switches, and then they can easily onboard and secure the end devices. So let's see the configuration for this feature. First is the device profile over lag configuration. So this is the basic device profile configuration. There's no change as part of that in 10.13 release. So first we will try to configure a LLDP group. So this LLDP group can match based on system description, system name, or vendor OUI. Next, similarly, we'll configure a CDP group, and it can match based on the platform, software version, or the voice VLAN query. And last, we have the MAC group. So this can match the source MAC address from the end device. So it can either match using the actual MAC address, MAC mask, or the MAC OUI. And once these match conditions are configured, the next comes the rule part. So once there is a match, there should be a result for it. So the result of this match is the rule assignment. So where we can do a set of rule parameters assigned for the end clients. So next part is the device profile configuration. So we have created the groups and then a rule. So we need to now associate the created groups and then the rule. So we have associate CLI to associate the corresponding rules and then the groups. So this is the global CLIs. Those are available prior to 10.13 as well. So next comes the enhancement over the lag. So this could be done in a non-secure mode. Means I wanted to enable device profile globally and let it be applied to the all the switch ports in the switch, and then there is no security on that. Like if there is a match, let it be onboarded. If there is no match, whatever is the port level attribute, let us return it. So that is the device profile overlap in a non-secure mode. So for that, the configuration is simple. Just you have to create a lag interface, and then what is the default lag configuration, that is sufficient. Globally, when device profile is enabled, then once the device profile configurations are matching, it will be applied to the lag interface. And if there is no match, there won't be any blocking of the port. The port will be open. Next is the secure mode, where we wanted to restrict, like only if there is a match, I wanted to unblock the port. So for that, we need to create the lag with these CLIs mandatorily. So as I said, if you wanted to move the client as a secure client, and the port has to be blocked, and only it can be unblocked with the secure device onboarding. We need to configure the port access device profile mode as block until profile applied. And we can set the client limit, like how many clients has to be onboarded in this lag. So only those clients can be allowed. The rest of the clients will be in a denied state. And to bypass the LLDP and CDPs for the matching, that is the device profile matching, we'll try to enable this allow LLDP BPDU and allow CDP BPDU CLIs. So overall, this is the picture of configuration required for the device profile over the lag. So far we have seen the device profile over lag configurations in the interface level and then the global level. So apart from that, we have other security configurations also available. Those are applicable even for the device profile. So those configurations will be present from this 10.13 release. Previously, these security configurations are not present. So as discussed earlier, there will be CDP and then the LLDP BPT allow, and there is other configuration called allow CDP auth and then allow LLDP auth. So these are pre-existing configurations. Previously, they are supported only on the physical L2 ports. Now they will be supported on the interface lag level as well. So these configurations are the restricting whether we wanted to do the authentication via LLDP or CDP or not. By default, they are enabled. If you wanted to disable the authentication trigger using LLDP and CDP, we can disable this allow LLDP and CDP or CLIs. And next is the allow CDP proxy log off. This is also a pre-existing feature. The main functionality of this is like if a phone connects to the switch and if it sends a proxy log off on behalf of the PC behind it, whether do you wanted to terminate the PC or not. So that is handled by this allow CDP proxy log off feature. So this is a pre-existing feature now being introduced in the lag as part of 10.13 release. And we can control the authentication mode of a lag interface. Either it can be a client mode where every device has to be authenticated, or it could be a device mode. Once the first device onboards, the port is open. Later on, any devices behind it can have the network access. And we can configure the client limit, and it varies from platform to platform. The other important one is allow flood traffic enable. So we have silent devices also connected over the lag. So by default, when we have the secure mode as block until profile applied, what happens is both the ingress and then the egress direction will be blocked. So if we wanted to send some wake on LAN packet or wake up the silent devices, we need to open up the egress path. So for that purpose, we need to enable the CLI allow flood traffic enable. So this is a pre-existing security configuration now available in the lag as well. And then the hero configuration block until profile applied to make sure the board is blocked until the client onboards. So next, how these configurations can be done via a REST API. So these are interface level configurations. So we need to go to the system interface context, and then for the particular lag interface, we can enable this CLIs. I have given a sample for one of the secure mode configuration, that is device profile mode set as block until profile applied. So apart from that, the other configurations previously discussed also available in the same system interfaces context. So let's go into the details section. First, let's see about the device profile modes. The first one is a client mode. So what is a client mode? So consider a access switch connected to a mini access switch, and that mini access switch has been connected with end devices. So if you wanted to securely onboard the mini access switch, we will connect a lag interface to the main access switch. So in that case, if it is a client mode, the problem here is every device that goes via this lag interface has to be onboarded. Only then they will have network access. So what we will try to do here is, for that purpose, we will configure the device profiles specific to the end clients. So first, for this main access switch, there is a mini access switch connector. So we will try to configure the device profile for the mini access switch. So usually for switches, we will go for a LLDP group match. So based on the LLDP group match, associate the role as switch. So next is for the PC. So for PCs, we will try to use a MAC group. Based on the PC's MAC address, we will try to associate the device profile. And next for the printers, similarly, we'll go with the MAC group. So for each end device client, you have to configure a device profile and then the match condition and then the corresponding rule assignment. So only then the devices can be onboarded over the lag interface. So if you could see here, when we do the show port access clients interface lag one, so it will list all the end devices connected to the main access switch. First is the switch, and next is the PC, and then the printer, and then the mode is set as a C, that means a client mode. So next comes the device mode. It is majorly used for the APs onboarding. So where we have dual port APs connected over the access switches, and we'll have the APs behind it either doing a local switching or over the gateway. So here is the configuration required for the device profile modes with the device mode. So first we will try to configure a role for the AP, and then we'll make as a auth mode device mode. And then we will associate the LLDP group created already and then the role assigned here. So once the AP onboards, you will see here only the AP's ETH0 base MAC address and then the mode set as D, that is the device mode. So if we have clients connected behind the AP, so those MAC addresses will be learned without any further authentication because the AP has onboarded and it has opened up the port, and later on any clients behind it, since it is a local switching in our case, it may have the access to the switching and they are allowed without any security. So these are the clients behind the AP now. First the AP is onboarded, later on the clients behind the AP are allowed the network access. The next major thing is how can we protect different devices onboarding in the same lag? So that we call it as a secure device onboarding over lag. So consider the configuration where I have a LLDP group created with the name as dual AP group, and then I'm trying to match it with the model, like if it is a 325 AP, then associate a role called dual AP. So interface level, I'm doing the configurations as a secure device profile onboarding. So I'm making the port access device profile mode as block until profile applied and auth mode as device mode, and trying to bypass the LLDP and CDP by BPDUs. First let APA be connected. So once the APA is connected, we could see here the AP is being secured because we have a match that AP is of model 325 and the LLDP system description correctly matches it, and then it is applied with the role dual AP, so it has been moved to a secure status. Now in the other port of the lag, I have not connected any AP, so it is in down state. Either we should have connected the other port of the AP, but I have not done it, so it is in down state. So what I will try to do here is I will try to connect a different AP in that port. So this is kind of negative scenario, or admin by mistakenly he is trying to connect a different AP to the same lag interface. This is not the ideal way to do it. So how switch can protect from such admin mistakes? So once the different AP device is connected over lag, mainly only this happens in a device mode with block until profile applied. So what happens is this APB will be blocked. Only the APA will be allowed and the APB will be in the block state because the device types are the devices are of different types. They are not of the same types. So how do the switch can do that? So this could be achieved using the LLDP packet walkthrough. So this is the LLDP packet from the APA and this is the LLDP packet from the APB. So if you consider here the LLDP packet from APA will have the chassis ID of its, and for the B it will have its own chassis ID. When the AP is trying to connect to the switch over the device profile with the block control profile applied. The LLDP chassis MAC ID will be checked. So this is the APA onboarded and this is the LLDP chassis MAC ID of APA. Now, if a different device tries to onboard it, whether the LLDP chassis MAC address is same or not, it will be verified. Here, it is a different one. So we do not allow different chassis IDs to be onboarded over the lag interface, and that is the reason the APB has been blocked. So this is achieved using this port access device profile mode as block until profile applied. So majorly it tries to guard such scenarios like you cannot connect different end devices in device mode in case of a device profile overlap. We have to connect only the same device types. That is also the use case of this feature requirement. So let's hear about the best practices to be followed for this feature. As discussed, so the device mode should be used for lags connected over the dual home AP for best results. If you go for client mode, each and every port on the AP will be trying to onboard and it may create a address moves. For that purpose, we have to have device mode for the AP connected ports. So if we have multiple device profile matching the onboarding clients on lag interface, consider I have a phone. I wanted to do a LLDP based match on one device profile, CDP based match for one device profile. In that case, we should configure a same rule in both the device profiles. If you configure a device profile with different rules, then whoever comes first will be applied. That is not the ideal case. So either you have to configure a single device profile. If it is multiple device profiles, the rule assignment has to be same. Next one is we should avoid adding pre-configured interfaces to the lag. So consider I already have some security ports and now those ports have been added to the lag interface. That becomes assumption like the existing configurations for the port will be retained, but that is not the case. So once the interfaces are added to the lag, the pre-existing configurations will be completely cleared. So this device profile, once it is enabled globally, it will apply to all the L2 and L2 lag interfaces in the switch. So if you want it or not, it will be enabled. So in that case, we have to be cautious in identifying what type of rule has to be done to the what type of end device type. So we have to configure appropriate rules based on the device type. So next is the client limit should be configured as per the number of interfaces in the lag. So consider I have 8-port lag. So when I try to configure the client limit as 3, then this is not acceptable because there could be chances of 8 devices can be connected over the lag. So the client limit should be configured as per the number of interfaces in the lag. As I said earlier, in case of silent clients connected in secure mode, it is advisable to do the port access allow flood traffic CLI. So it can able to send the equivalent packets to make the silent end devices. So let's see the demo. So here is a three-tiered architecture where I have the access aggregation, the core switches, and my AP is being connected to the access switch that is a two-member VSF 6300 box. So I'm using AP 555 for this purpose, and it is connected over lag interface to the conductor and then the standby, ETH0 to the conductor and ETH1 to the standby. So this is the configuration I'll be using for the demo. So first is the LLDP group creation. So I have created a LLDP group based on the system name match. This is the system name for the API I have used. So I'm using this as a match criteria. And then based on the role requirement, you can configure a rule. So I have created here a dual homed AP rule with the auth mode as a device mode and the VLAN based on the VLAN requirement. And next is the device profile enablement. I have associated the configured LLDP group here and then the rule. So when it comes to the interface, I wanted to be it a secure onboarding device. So for that purpose, I have enabled the mode as block control profile applied and then the bypassing the LLDP and then CDP BPDUs. So first let's see the show version in the switch. So it is in current 10.13 version. So here is my VSF switch. I have conductor and standby present in it. So let's see the LLDP neighbors first. So I have a dual port AP, that is AP 555 connected over the port 113 and then the port 213. So let's see the detail about those APs. So I'm doing a show LLDP neighbor info. First the third port. So here in the third port I have ETH0 connected from the AP, and next with the other port in the standby I have ETH1 connected here. So first let's see the neighbor information, whether what is the chassis ID present in it. In both the cases, if you could see here, the chassis ID is the ETH0's MAC address. So this is the criteria for the device mode. The chassis ID should be same for the in devices connected over the LAN in case of security. So I'm trying to enable the debug destination buffer and then the debug port access. So later on, we will see the workflow, how the debug logs is able to print the device onboarding. So we'll now jump to the configuration part. So this is the configuration that I have created, the LLDP group with the match criteria as system name. So I'll try to do that configuration first. So here the LLDP group created is dual ohmed AP group, and it is based on the system name as match. So I got it from the LLDP packet. So the APs are configured with this system name. So now is the role configuration part. So I'm now create a role that is a dual homed AP role with the auth mode set as the device mode. So next what we will do is we will try to configure the device profile configurations. So we will try to associate the configured LLDP group and then the role here. And globally, this device profile configuration has to be enabled. So this is the device profile configuration where we are associating the role created and then the LLDP group created. So next comes the lag configuration. Since it is a secure device onboarding, I wanted to do a secure configuration over the lag. So let's hear about it now. So we'll go to the interface lag one and then we'll make the lag interface configuration. So in this configuration, what I have tried to achieve is I have made the LACP mode as active and then I have configured the other security configurations. So first is the AAA authentication port access allow CDP BPTU, and next is allow LLDP BPTU, and the device profile mode I am trying to configure as a secure mode, that is block until profile configured. So now we'll see the show run interface lag one to view the details whether the configuration which we made has been applied. The configuration has been applied. So we will now try to associate the interfaces to this lag. So we'll go to the interfaces and then we'll make it for the lag one. So now the interfaces has been associated. So let's check the show port access clients interface lag one to view whether the AP has been onboarded. So here we can clearly see that AP has been onboarded over the lag interface. If you want additional details also, we can view it. So it will clearly shows the device profile configurations over the lag interface for this particular AP. What is the profile name and then LLDP group, and then whether the device profile status is applied and what is the corresponding role configured for this. So now let's see the interface level secure status. So we'll do a show product interface lag one status, and it will clearly shows that both the interfaces are now secured over the lag. So this is the ideal way for configuring the device profile for the lag interfaces. So now we will do a LACP interfaces show command. So reason being is only when the interfaces are secured, the LACP will be forming between the switch and then the AP. And now the LACP has been formed and the forwarding state is also up. So now let's see the debug informations. What type of debugging is present when we have enabled the debug for this port access model? So I'm using the show debug buffer for that. So here is the sample debugging available. So if you could see here, this device profile once applied, it is for all the ports in the switch. So one of the port like 113 where the AP is connected, there is a neighbor match. So it clearly prints there is a neighbor match for that particular port. So only if there is a match, then it will be applied the device profile. But if you see the other ports and all, there is no match because I have not configured the device specific device groups for those end devices. So for them, it will clearly show that neighbor is not matched. So if you wanted to identify the role assignment, that is also available in this debug buffer for this port access model as well. So I'm reusing this CLI again, but I'm trying to use a filter here as a rule. So once this filter is placed, we can view the rule assignment. So this is the debug information for the rule assignment. So let's see for the particular dual port AP. So here it shows like the dual port AP has been successfully authorized with the role as dual ohm AP. And then even the secure client is changed for this port, like it has been authenticated with the role. And since device profile is a kind of bypass role, it prints as bypass role is set in the lag for this particular client to the role dual home AP. So this is how we can able to view the role assignment and then the neighbor matching using the single debug port access device profile debugging itself. So with that, we have come to the end of the demo session. So with that, we have come to the end of the session. Thank you everyone for watching this video. If you have any further queries, do reach out to us in our AREDS community. Thank you all once again. Bye.